Welcome back. We are going to be talking about gases in this collection of videos, and I think I said there was going to be a parade of equations mostly named after dead guys. Here is our first dead guy. His name was Boyle, and he has an equation known as Boyle's law named after him. And here is the setup for Boyle's law. Most of these examples are going to involve a balloon. So let's pretend that I have a gas in a container, and it is a gas inside of a balloon. The balloon has a certain volume, which I'm just going to abbreviate with the letter V. Right? You can agree that the gas inside the balloon takes up a certain amount of space, which we call volume, and we can put a number on that. The gas inside of the balloon pushes against the walls of the balloon and exerts what we call pressure, and the external air pushes back against the balloon with an equal amount of pressure, which I'm going to abbreviate with the letter P. What Boyle's law says is if I increase the outside pressure on the balloon, in other words, if I make the outside pressure stronger, I push against the balloon from the outside more, the volume of the balloon is going to go down. So basically, if the pressure number gets bigger, that's why I drew a bigger P, the volume number gets smaller. And this happens in reverse too. If I decrease the external pressure against the balloon, so if I make the P number smaller, the volume of the balloon will get bigger. So if I push, if the pressure on the outside increases, the balloon will shrink, and if the pressure on the outside decreases, the balloon will get bigger. That's sort of shown here. Here's a smaller balloon, here's a bigger balloon. Boyle's law says a little bit more than that. What Boyle's law says in a little bit more detail is if I double the outside pressure, then the volume of the balloon will go down by double. And if I triple the outside pressure, the volume of the balloon will go down by triple. It didn't have to be that way, but that appears to be the way that it is. And here is an example. So here's a balloon. Those arrows on the inside of the balloon are supposed to be showing you that the air in the balloon is sort of pushing and giving a force against the walls of the balloon. And there's the outside air pushing against the balloon as well. And the pressure of the balloon under these conditions I'm going to call P1. That means the pressure at the beginning. And the volume of the balloon, basically how big this balloon is at the beginning, I'm going to call that V1 for the volume at the beginning. And what Boyle's law says is if I make the pressure, let's say, get twice as big, so you can see the arrows are thicker, then the volume is going to get twice as small. And there are 2's next to these P's and V's because the P2 means the pressure at the end of my experiment and V2 means the volume at the end of my experiment. And the way that Boyle's law is usually written is like this. Pressure 1 times volume 1 is equal to pressure 2 times volume 2. So, and you can think of this as, I kind of try to think of this as a seesaw, and if I make, and the seesaw has to end up balanced no matter what. So on one end of the seesaw I have P1 and V1, there are certain numbers, and basically if I make the P2 number go up, then to keep this seesaw balanced, the V2 number has to go down by the same proportion. So the V2 number has to get smaller just so that the seesaw stays balanced. But you're not going to see any seesaws on quizzes or exams. You're going to have to use this type of equation. Don't memorize this equation. I will give this to you on a quiz or a test, but you're going to have to be able to use it. This is I'm going to show you a video of Boyle's law in action. It's a little bit silly, but here it is. So what you're going to see in this video are these marshmallows that are mostly filled with air, so you can think of these things as basically being balloons. They put this marshmallow that is mostly filled with air inside of a container where they can mess with the pressure. And what they're doing right now is they're decreasing the pressure on the outside of this marshmallow, and the volume of the marshmallow is getting bigger. There's the Boyle's law equation. They're decreasing the pressure on the outside of the marshmallows, and the marshmallows swell up. And I think they're going to crush the marshmallows in a second by increasing the outside pressure. Yeah, it says increase the pressure. And now they smush the marshmallows. So there's Boyle's law in action. You can do math with this. We are going to do math. So here's a practice problem. Here's the setup. You have a balloon with a volume of 3 liters and a pressure of 1 atm. You change the pressure of the balloon to 4 atm. So you change the outside pressure on the balloon to 4 atm. What's the new volume of the balloon? So you can pause and work through this. I'm going to work through this myself. We're going to need Boyle's law, which is pressure 1 times volume 1 is equal to pressure 2 times volume 2. And all we do in these types of problems is we go through the question, find the different numbers and put them where they need to go. So 3 liters is a volume, and that's the volume at the beginning, so it's going to go there. 1 atm is a pressure at the beginning, so it's going to go where P1 should go. So 1 atm of pressure is equal to, you change the pressure of the balloon to 4 atm, so that's the new pressure. And the question is, what's the new volume? And that's this one. So we don't know what that one is, so we're just going to call it V2. And then we need to get the V2 alone, so we're going to divide both sides of the equation by 4 atm. If we divide the right side by 4 atm, the 4's reduce away to 1, the atm's cancel. We have to do the same thing to the left side. We have to divide the left side by 4 atm as well to keep it equal. On the left side, the atm's will cancel. The only unit that I have left is liters, which is what we want because liters is a measure of volume, and the question says we want to know what the new volume is. So just to rewrite this equation, 1, that's coming from here, times 3 liters, that's coming from here, divided by 4, that's coming from here, is equal to V2, and that's coming from here. And so what's 1 times 3? That's 3. What's 3 divided by 4? That's 0.75, and the only unit that was left is liters, so the answer is 0.75 liters. Now if you don't trust your answer, you can do what I call a sanity test. You can at least see if the number that you got makes even a little bit of sense. The balloon, here's our balloon, at the beginning had a volume of 3 liters, and the outside pressure was 1 atm, so pressure pushing against was at 1 atm, and then we increased the pressure by 4 times. The outside pressure got 4 times stronger, and so what that means is the balloon better get smaller. So whatever number we get, it better be smaller than 3 liters. This number is smaller than 3 liters, so at least by that measurement we did our sanity test and we did not go insane. So that is Boyle's law. That's our introduction to Boyle's law. That's the end of this video. The next video is going to be a law called Charles's law.
You'll be crying, those teardrops, oh, will fall